Okay, we are at 5 after now, so I guess we'll get started. If more people come in late, there's not a whole lot of the actual content of the course right away, so they do have some time to come in, but we'll go ahead and start anyway. So welcome everyone to What That Mouth Do, which is an introduction to speech production and synchronic sound change. What those parts of the subtitle mean: first of all, speech production is pretty straightforward. It is how you produce speech, and then synchronic sound change is how sounds and words become different based on the based on the sounds around them in sort of real time. And so those are the two kind of components that we're going to focus on mainly in class today. I did initially plan to get to a bit more than I think we're going to have time to. And I did get some feedback from teaching this yesterday that a lot of the students were really interested in getting to Pig Latin, but I'm not sure how realistic of a goal that is. So what I'm going to do for everyone is drop a PDF of my slides in the chat, so that if you want to, keep this to, look back on or look at later, or if you want to get to material I had planned to cover that we won't have time for, you can do that. So I'm going to put the slides here so that everyone can have access to that. And I will just need to try to remember that for later if more people come in. So we're going to go ahead and get started then with the content of the course. And first thing I'm going to do is introduce myself really quick. So my name is Trevor Driscoll. Hello, everyone. I'm doing my PhD in linguistics at MIT right now. I started that in 2020, so it was the best time to start going to a new school during the pandemic where I wasn't allowed on campus. That was really great, but very excited to actually be allowed on campus in the fall. So it'll be like my first time, going around campus and actually going to school at MIT. So that's very exciting. I did my bachelor's and master's degrees in California. They were also in linguistics. I actually started out interested in teaching ESL, but I became more interested in sort of the more scientific and theoretical aspects of language instead, going through that course of my education. But as you can see, I bounced around California a bit, and while I was in school, I was also working mostly as a teacher and tutor. Until 2018, I was in California. Then I moved over to the East Coast and I taught in Queens and community college in New Jersey. Thank you, Jacqueline. So I taught mostly ESL, and then for my TAing and tutoring, I was working in linguistics a bit. I'm sorry if this is terribly boring to some of you, but I had heard that students were kind of interested in what their teachers did and all of that. So I don't know. This is here if you care. If not, you can kind of tune it out. So I've had some of my work published on linguistics. A lot of this is just kind of nonsense to most people because it's just very technical. So I had some work I presented at a conference that got published, and then I put together more proceedings for other conferences that I was part of organizing. And then I had some literature published in Spanish and Italian. And then this is some of my research that I've presented in various parts of the US, and then England and Canada as well. So that's all there if you want to try finding some of that, or want to do more reading about what I do specifically, which does kind of involve the stuff you're going to be learning about today. And then the more fun things that I kind of do that aren't strictly research based is field work, where I would basically go on to working on indigenous American languages, so going on reservations. So I went to Crowland. This is in Montana. That was really cool. I got to be on the reservation there for about a month. And then I worked on a language spoken in Oaxaca called Mixtec, and then Passamaquoddy, which is spoken up in Maine. And then, so that's some of the more fun stuff I got to do. And you can also do with an education in linguistics if you're interested in working with sort of revitalizing and documenting endangered languages. Linguistics helps with that. And then a couple of really cool things I'm pretty proud of is that I helped work as like a code breaker in a murder trial in California. And then because of that, I got to do some consulting stuff with the FBI. So those are some fun extra bits of stuff I got to do because of my sort of work in linguistics. So all of that's lots of fun and the kinds of stuff you can do if you pursue an education in linguistics. So now we're going to cover what we're going to do today. We're going to learn about what speech is and how it's made. That's the speech production part of the class. And then how sounds change under the influence of nearby sounds, which is the synchronic sound change part of it. And then we were also going to learn about the structure of sound if we had time. Not very sure that's going to happen, but we would be learning about the science of Pig Latin, and that is in the slides if you want to look at those later on. So before we do anything, first questions I want to ask all of you. Oh, I forgot to mention, if you do have questions at any point during the class, you are welcome to just unmute yourselves and kind of interrupt me. I don't consider it rude. You don't need to raise your hands or anything. Just go like, hey, I have a question, or this doesn't make sense, or whatever. If you need something clarified, that's all perfectly fine. You can also use the chat. I encourage you to put any questions you have there. I'll get to your question in a bit, Ronan. Is you can put questions in the chat or comments or whatever. All of that is perfectly fine and kind of lets me know that you're following along with the class. So that's all good with me. Don't particularly care if your cameras are on or off or your mics are muted. That's all, whatever you're most comfortable with is fine with me. So Ronan, a code breaker basically takes some kind of disguised speech. Pig Latin is something like that, where you sort of mix around the sounds in some way to hide what you're saying from other people, so that the only people that can understand you are people who also know the code. So for Pig Latin, like my name is Bob, you'd say aimne is a abbe. And you can only get that message if you know how Pig Latin works. And so in my case, it was a different code that doesn't really have a name. It's kind of the first time ever encountering it. But say my name is Bob, you would say Maidaka Nemika Edika Babaka. That was applicable to the case. I can. So in prison, the speaker was using the code to sort of communicate with family and friends about details of the case and alibis and things like that. So we figured out what the code was and then basically found out what they were saying to their friends and family about the alibi and what happened with the case. And so that was kind of our relevance to the trial. So good questions, thank you. Now, before we start with getting into speech production and the material, I have a couple of questions that are very difficult for most people to answer in a really scientific way. So if I say, what is a consonant and what is a vowel? My guess would be that your response is just going to be to list consonants and vowels in a particular alphabet. So in the English alphabet, your answer to what is a consonant would probably be B, C, D, F, G, H, J, and so on, where you just list the consonants that you know. And same thing for vowels, A, E, I, O, U, and maybe Y, if you were taught that Y is sometimes a vowel. But that doesn't really get to the heart of what this question is really about. That's just a list of consonants and vowels. It doesn't really say what they are. It doesn't say what defines a consonant and a vowel. And so that's the kind of thing that we're going to be looking at today. Next part that's important about understanding speech production is what speech really is. So speech production and speech is really just a continuous stream of sound, where sound is really just the vibration of air molecules. And how that ends up working is that some vibration patterns of those air molecules are recognized as speech sounds by the brain. And when they pass through your vocal tract, that's sort of your mouth, nose, and your throat, those vibration patterns change based on the anatomy that's involved in producing the sounds. And so some sounds are recognized by the brain as speech sounds, or what we would call phones, when they enter in your ear. And then you have receptors in your ear that sort of recognize those vibration patterns, and then you pull out of those vibration patterns a message. You get meaning out of it. And so that is, at its core, from sort of a more physics and acoustic standpoint, what speech is. And so we're going to be learning about phones and the vocal tract and how we make those vibration patterns that we recognize as speech sounds. Right, so in order to do that, we do have to learn some anatomy about what's involved physiologically in producing speech. But this, kind of learning anatomy is a little bit different and more fun than the kind of anatomy that you learn in health class about how your body is changing. This is less awkward, much more fun. So we have here a diagram of a nice volunteer to be cut in half. So this is the side view of a human head, where you can see inside of the oral cavity where the tongue is here, and also the nasal cavity and the inside of the throat, which are going to be the important parts for our class today. So we're going to start by looking at the anatomy of the vocal tract. So there are different components of the vocal tract that are all important in producing speech. I'm going to pause briefly because it looks like there are some new people who may not have gotten the PDF of the slides. So there we go, dropping the slides again in the chat. So the slides, again, are just going to be made available as a PDF for you to hold on and refer to later. Now, the moving articulators are the portions of the vocal tract that are able to move. As you can imagine, there are some parts of the vocal tract, like the roof of your mouth, that you can't really move. There are some parts that you can move. So that would include the lips, primarily your bottom lip, your tongue, and then also the pharynx, which is further in the back of the throat, here, sort of behind your tongue. And so these are the parts of the vocal tract that are in a lot of ways responsible for making most of the sounds that you produce in speech. The next important part are places of articulation that the moving articulators sort of make contact with to constrict airflow as air passes through the vocal tract. So some examples of places of articulation would be like the lips, teeth. The alveolar ridge is probably a bit more unfamiliar. So you can find the alveolar ridge in your mouth by going with your tongue and sort of feeling behind your teeth, usually around where you would get peanut butter stuck in your mouth. But if you move your tongue across the roof of your mouth, you can feel this little bumpy area. I'm doing it now. And you feel like a series of bumps. That is your alveolar ridge. The palate is maybe a little bit more familiar to everyone, but it's not necessarily what we think of in the most common usage of the term palate when talking about food or cooking. This is actually at the top of your mouth. So usually if you eat pizza that's too hot, this is, you would burn your palate if you ate pizza that was too hot. So that's at the roof of your mouth, a little bit further back. We'll get to the velum in a second. That's right behind the palate. The uvula is like the little speed bag hanging in the back of your throat. A lot of people mistakenly identify that as the tonsils, but that little dangly bit that kind of looks like a speed bag, that is your uvula, where you can also make some sounds there. And then You can also touch your pharynx either with the back of your tongue or your epiglottis, which is this bit here, sort of behind and underneath the tongue. So those are places where you can constrict airflow with your tongue, or in certain cases, like, as you may remember, lips are one of the moving articulators. So some of these parts are touched by different moving articulators in speech sounds. Next important part of the vocal tract is the velum. So the velum is kind of like a valve. It can either be open or closed, and the function of the velum is to divert airflow. So you can either have the velum closed, which will send air into the oral cavity where you have your tongue and your teeth and your lips, or the velum can be open and air can go into the nasal cavity, because air basically follows the path of least resistance. So if the velum is closed, instead of going up into the nasal cavity, it will go and sort of make a turn into the oral cavity. But if it's open, then air will just go straight up into the nasal cavity. So that's the function of the velum, in addition to being a place of articulation where you can constrict airflow. It also decides which of the cavities in your face air will go to. Hold on. I just need to check something really quick. Okay, good. I am using the correct microphone. I was unsure of that. So the next part of the vocal tract that's very important is the glottis, or what's more commonly referred to as the vocal cords or the vocal folds, which can have a number of different settings. And because all of the air passes through the glottis, that gives the glottis an opportunity to affect the quality of sounds as air passes through it. So if the glottis is sort of spread out of the way, then it doesn't really have much of an opportunity to affect sounds. And so you get just kind of like a breathy kind of quality, sort of like you're whispering, or you get sounds that have puffs of air at the end of them when the glottis is spread, because it doesn't really obstruct airflow when the vocal folds are moved out of the way of the airstream. Another thing that the glottis can do is it can vibrate. And because of that vibration, it sort of adds additional vibration to the air molecules as they pass through the vocal tract. So you get sort of a buzzing kind of sound. So in a sound like zzz, your glottis is vibrating, and you can actually feel this in your throat with your hand. If you say a bunch of different sounds, so like zzz, you can feel the vibration of your glottis through the outside of your throat. Same thing with like, you can also feel vibration there. Another behavior of the glottis is that it can close completely, which basically stops any air from getting through. And because there is no air passing through the vocal tract, that stops all of the sound entirely. So if you shut your glottis, we actually have this in an English kind of phrase. It's called the glottal stop. So in the, it's not exactly a word, but when you say, uh-oh, where I have written the hyphen there, that is where the glottis closes and stops air between and o. Ronan, what happens with laryngitis? I am not a doctor, so I can't really answer that question very well, but basically your larynx, which is here, right? Because it's itis, that means it's swollen. And that has some kind of effect on sound. I don't really know what happens when people have laryngitis. That's not an area I specialize in, but it is reasonable to think that if the larynx is swollen, that will also somehow impact how air passes through the vocal tract, and will in some way change the quality of speech that you produce. Hopefully that is a satisfying answer, and a satisfying enough answer to your question. Unfortunately, that's not really an area I study. Okay, good. All right, glad I could help. All right, so that's the glottis. These are all of the major portions of the vocal tract and sort of their functions in the production of speech. Um, what happened? What happened? What happened? Okay, that's what happened. So now we're going to go through the process of, now that we know the anatomy involved, we can look at the process of how you actually make a sound from start to finish. So first, in order for you to have air to make a speech sound, right, air needs to come from somewhere, and so that is primarily the lungs. And so air leaves your lungs and goes into the vocal tract through the trachea, where the glottis is sort of sitting on top of it. Once the air leaves the lungs and it passes through the glottis, that will give the glottis an opportunity to change the quality of the sound. And depending on its setting, it will add, it will make different changes to the phone. So if it's, again, vibrating, it'll give it more of a buzzing quality. If the glottis is spread and it doesn't really obstruct airflow, then you'll have more of just, like a breathy kind of sound. Or if it's closed, it won't let air through. And that's something you can also kind of hear as well. Once air passes through the glottis, it goes up by the larynx and sort of behind the tongue, where the next crucial part is the velum, where it will either send air into the oral cavity when it's closed, or it'll let air into the nasal cavity when it's open. And whether air passes through the oral or nasal cavity also sort of determines how the sound behaves, just because of the acoustics and the space involved with how open the oral and nasal cavities are. So let's say, for the sake of argument and illustration, that we currently have the velum closed, and so air gets sent into the oral cavity. Then at that point, a moving articulator, for example, the tongue, will make contact with a place of articulation. So it'll find somewhere in the mouth and impede airflow in some way. So if the tongue moves to the alveolar ridge, for example, that restricts airflow and that kind of briefly stops it. Or it can kind of restrict it in other ways, depending on how tight the constriction is between the moving articulator and the place of articulation. Then the articulator moves away from the place of articulation, and air can continue passing through the vocal tract to exit the mouth through the lips. And again, this would work much the same way if the velum had been open and air went into the nasal cavity, the only difference being that air would come out through the nose instead of through the lips. So this is more or less start to finish how a phone is produced. And so we can actually see this happening in action with these little MRI videos. So we can see, just to sort of brief everyone to show what they're looking for, you want to watch this. Here is the tongue, and the velum is back here. Right, and this is, I think, the nose up here, and then the lips. But since this is a ta, right, that this is not a case where air goes through the nose. So the velum is going to be closed the entire time, and you'll get to see that in the production of the sound sequence ata. Ata. So I'll play it again. And again, keep an eye on this here, the velum. Ata. You can see it's pressed up against the back of the throat the entire time. In contrast to that, we have ana, where we do let air pass through the nose. So again, watch the velum here. You'll see that it opens when producing the N. Ana. So it's really brief and subtle, but you can see that there is a gap between the back of the throat and the velum when the speaker says right, ana. Ana. You see the velum moves back and forth to shut air during ah and let air into the nose during So that's a bit of seeing the velum in action. Ana. And there it is one more time. All right, so that is a sort of real-time look at how the anatomy moves in the production of a phone. Yes, Jacqueline, I can play the first one again. Ata. You see the velum stays up the entire time. Gonna pause for a second, just check. Okay, good. All right. So now it's going to be your guys' turn to sort of think about the way that your moving articulators and places of articulation work. So in the first consonants of each of the words I've given below, right, B, Fi, T, Ni, and Ki, I want you guys to think and put in the chat, or you can just unmute yourselves and speak. Right, so say what is the moving articulator involved, right? It's either going to be your bottom lip or your tongue, and then think about what part of the mouth, what part of the mouth the moving articulator is touching. So again, I have the chart here. The important ones: lips, teeth, alveolar ridge, palate, velum. English does not have uvular sounds, so I can rule that out for you. All right, so for B, what's our moving articulator? Right, lips is the moving articulator for B, and what is your bottom lip touching when you say B? Top lip, yes, good, Ronan. It is, so here the moving articulator and place of articulation is both going to be the lips. So what about Fi? Fi. I'm just gonna have a drink while you guys are doing that. Right, this does again involve the lips. But you're, I'm not sure if you're specifying moving articulator as the bottom lip or place of articulation is bottom lip. Not quite. So if you had both lips for Fi, it would come out sounding very similar, but slightly different. Yes, so Ronan, there are two Ronan. Oh, that's a bit messy. Yikes. Okay, but Ronan with accent marks. Yes, place of articulation is the teeth. So your bottom lip is making contact with your teeth in the production of Fi. Good. All right. So what about T? Good. Tongue is the moving articulator. And what does the tongue touch? Yes, good. Taruna, it touches the alveolar ridge. Long O and long A for accents in Ronan. Thank you. I will be more mindful of that, Ronan. Hopefully I did that right. Yes, so in T, the tongue is touching the alveolar ridge. Good. And what about Ni? Good. This is also tongue and the alveolar ridge. A fun little trick you can do with that is if you switch between saying T and Ni, you don't really need to move your tongue at all. So t, t, n, t, n, t, n, t, n. Your tongue stays in the same place. The only difference there is actually whether your velum is open or not. So in T, the velum is closed, and in Ni, the velum is open. This one is a little bit harder. What about Ki? Ki. Good. So Ronan, it is close to tongue and palate. Soft palate. Yes, this one is going to be the velum. Good, Leanne. Yeah, when you get further into the back of the mouth, it's a little more difficult to differentiate between what your tongue is touching, partly because when you're making contact with the velum or uvula or pharynx, you are using the back of the tongue, which is not as well trained to be sensitive to differentiating the different parts that you're touching. So good, did very well with identifying moving articulators and place of articulation. All right, so one of the important aspects of sounds that you can identify a little bit more specifically when you want to categorize different sounds is you can sort of sort them by their place of articulation. And they all have different names depending on basically what touches where, right? What's the moving articulator and what's the place of articulation. So when you make a sound with both of your lips, right where your bottom and top lip touch, those sounds are called bilabial. And these, the names might look a little bit scary at first, but there's a neat little trick you can do to sort of break them down and make them less scary. So the first part is that they always refer to the anatomy that's involved in producing the sound. So that's always a big help, where if you know the anatomy, you basically know what to call the sound. And in the case of bilabial, since you're using both of your lips, you have bi, two, and labial lips. That basically gives you instructions that say, if a sound is bilabial, you make it with both of your lips. And so examples of bilabial sounds in English are b, p, and me. The b, p, and are all made by touching your top and bottom lip together. The next one we have is labiodental. So again, this can be broken down into its different parts, where you have labial, or labio, again referring to the lips, and dental, referring to teeth. So labiodental sounds are made with your lips and your teeth. So sounds in English that are labiodental, involving the lips and teeth, are f, like in fee, and v, like in veal. And again, I encourage you to follow along to make sure I'm, not lying to you or anything, that these sounds do actually involve the lips and teeth. Right, so f has lips touching the teeth, and so does v in veal. You make some sounds by sticking your tongue in between your top and bottom teeth. And so those sounds are called interdental, inter for between, and dental for teeth. English doesn't have a lot of these sounds. There's really only two. But when you say thin, you can, I exaggerated it a little bit, but you can see my tongue kind of poking out from between my teeth. You also stick your tongue between your teeth in the production of this. So because the tongue goes between the top and bottom rows of teeth, you have what are called interdental sounds. And again, that's, with the tongue. When you make a sound where your tongue touches the alveolar ridge, those sounds are called alveolar, named again after the anatomy. So there are lots of these sounds in English. It's sort of the largest category. I wouldn't say exactly that most sounds are made at the alveolar ridge, but of any single place of articulation, the alveolar ridge is the one that has the most sounds. So in T, D, C, zip, knee, lead, and read, your tongue is touching or near the alveolar ridge in the production of all of these sounds. Okay. When your tongue is touching your palate when you produce a sound, those sounds are called palatal. Again, keeping in the tradition of naming sounds after the anatomy that you use to produce them. So in the words cheap, jeep, she, genre, and yeet, the tongue is making contact with the palate. And for sounds where you're touching your velum, and this is going to be with the back of the tongue, those sounds are called velar. So examples of velar sounds are key, gear, and the final consonant in thing. So that's very common with words that end in ing. Those sounds end with velar consonants, where the back of your tongue is touching the velum. So again, key, gear, and thing. There is one more that I didn't really include, mainly because you don't actually have a moving articulator making contact with it, but there are also sounds made entirely with the glottis, which are called glottal sounds. So one of them I mentioned briefly, the sort of gap between and o. When you say uh-oh, your glottis closes between the and the o. So that would be called a glottal stop. We'll get more into that a little bit later. But then you also have cases where you spread the glottis open. And so that's the production of an H sound, like happy. I left that out because there isn't really a place of articulation, mainly because if you look at the diagram here and you try to move your tongue down to touch your glottis, you will be unable to breathe and you will choke. So I don't recommend trying to touch your glottis with your tongue. It's not a good idea and it won't end well. So that's why the glottal sounds are left out here. Okay, I will pause briefly for any questions and again, have more of my delicious drink. This class is sponsored by Pepsi. Okay. So it looks like there are no questions, so I'm going to go ahead and move on. The next important component of producing sounds is what's known as the manner of articulation, which refers to the way that air moves through the vocal tract, and sort of more specifically how restricted airflow is during the production of an articulation. So when you have your moving articulators making firm contact with a place of articulation, so for example, the tongue touches the alveolar ridge and there's firm contact, there's no real way for air to get through. And so what that does is it stops the airflow. And so sounds that are made in that way with firm contact between a moving articulator and a place of articulation are called stops. If you have contact still, but it's a bit more gentle, then that does allow for the possibility of airflow through the constriction, but it generates a lot of friction when air passes between the moving articulator and the place of articulation. And because of that friction, those sounds are called fricatives. If this is going by a bit fast, don't worry, there's a chart summarizing sort of all of this coming up soon. The next sort of category of sounds is when a moving articulator is near, but not really touching a place of articulation. So one of those cases is like in the production of R. So in read, you might feel that your tongue isn't necessarily touching the alveolar ridge. And so this would be an example of one of the approximates. And it's named after the approximate contact between a moving articulator and a place of articulation. But because there is no actual direct contact between the moving articulator and the place of articulation, air is relatively free to go through the vocal tract. And so these sounds tend to be a lot louder than fricatives or stops. The next category of sounds is nasals. So these sounds are made again with the velum open, where air goes through the nasal cavity. Again, named nasal because air goes through the nasal cavity. So a lot of it sounds fairly complicated, but the naming conventions of everything are fairly straightforward. And if you know about the production of the sounds, then they're easy to create sort of mnemonic devices for, so you can remember the names of the different categories fairly easily. So these are the different manners of articulation that we can have for consonants. The next thing that can differ in the production of a sound is the behavior of the glottis. So what the glottis does as air passes through it, again, has an effect on the quality of a phone. And so when the glottal setting changes, then the sound becomes different. And so some of the most important ones are when the glottis is just kind of still and not moving. It's not spread or closed or anything like that. It's just sitting there being all plain and boring. these sounds are called voiceless. And the easiest way to remember that is that it contrasts with voiced when the glottis is vibrating. And again, that's something you can feel with your hand through your throat. So some examples of voiced sounds are like all vowels are voiced. So if you say E, you can feel your throat vibrating. And then some of the other sounds like B and B, M are examples of voiced sounds where the glottis is vibrating. When the glottis is spread and you get that sort of puff of air quality, yes, Ronan, I will give an example of voiceless sounds in a second. So when the glottis is spread and you get the puff of air, you can see those in, for example, like P, T, and K. And you can feel these with your hand. If you put your hand in front of your mouth and you say P, you should hit your hand with a little puff of air. So those are aspirated sounds. So returning to voiceless sounds, examples of these would be, the fricatives are sort of the best examples of these. So if you have like S, and if you produce that, you'll feel that there is no vibration in your throat. And that's how you can tell that the sound is voiceless. Okay, any more questions on glottal settings before I move on? Okay, so seems pretty good. All right, so these three different aspects of a sound are called features. So you have a different feature for place of articulation, manner of articulation, and glottal setting. And a shorthand sort of way to refer to these is like a place feature, a manner feature, or a glottal feature. So this sort of combination of place of articulation, manner of articulation, and glottal setting are what define the identity of every consonant. And because the change in place of articulation or manner of articulation or glottal setting makes the sound different, you can identify any phone by its unique combination of its place feature, its manner feature, and its glottal feature. So we're going to look at how that works briefly, right, with this fancy little chart that has all of the consonants of English in it -1, because W's are just a little weird. But W is the missing sound from this. So across the top here, the top, what are these? These are columns, right? The columns identify all the different places of articulation that you can have. So everything in this column is a bilabial sound, right? So P, B, and M. In the labiodental column, these are all labiodental sounds. So these are places of articulation across the top. And then here on the side, going from top to bottom, are the different manners of articulation. So the other convention in looking at a consonant chart is you see that there are some cells that have two sounds in them. And so the sounds on the left are voiceless. So if you feel your throat when you say P, you'll feel no vibration. But if you say B, 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 you do feel vibration. So in the consonant chart, the sounds on the left are voiceless and the sounds on the right are voiced. That tradition gets a little broken for the approximants here. So L, and R are both voiced. So that's just kind of how they are, because you can't really write them on top of each other. But so just remember, for the approximants, L and R are both voiced. So these symbols, right, or letters, they all represent different sounds. Most of them, based on the English alphabet, make the sounds you would expect. So P sounds like P, B sounds like B, M sounds like F sounds like F. The only ones that are different from the English alphabet are this here. This is a Greek theta, which we don't have in the English alphabet, and this one, and these two here. So I'm going to make the sounds for you briefly. So this one is like in thin. This one is like in this. This one here is like shh, like you want people to be quiet in a library. This one is zh. And then the two up here are ch and j. This one is written with the letter J, but is not pronounced like J in English, like in jar, right? That's this sound. So this is kind of like you're reading German, and so this is y. But you can use this chart to help identify the features. So you can name a phone after the features it has by kind of looking them up in this chart here, where P is voiceless, right? Because it's on the left of the cell. It's bilabial because it's in the bilabial column, and it's a stop, right, in the stop row. Same thing with Z. Z is a voiced sound. Z, right? It's on the right side of the cell. It's alveolar in the alveolar column, and then it's a fricative in the fricative row. Oh, this one I left out. This is like at the end of thing or being. This is the one that's written with ng very commonly. So I should also point out that nasals and approximants are basically always voiced, so they just go in the middle, and it's a little redundant to say a voiced velar nasal. But so this sound is velar for the place of articulation, and then nasal for the manner of articulation. And then y, the y sound, is palatal and an approximant. So this may come in handy very briefly, or should come in handy shortly. We're going to be doing something with this in a bit, so I'd recommend like taking a screenshot of it and having that. Or also, if you've downloaded it, just open the PDF and you can look back at the chart. We will be using that in a second. Okay, so all of that seems fun, neat, great, but really, who cares? Why does this matter? And the reason that this matters is there are certain people, certain groups of people that these things matter for. So for example, if you're interested in learning languages, you should care about consonant features because the fancy names for consonants like voiceless bilabial stop, those are actually instructions for how to produce that sound. It tells you what your glottis should be doing, what your moving articulator should touch, and how tightly it should touch it, right? So it says, don't move your glottis, touch your top and bottom lip, and stop airflow. So those are instructions for how to make any sound found in any language. This also matters for linguists because these three different features, right, place of articulation, manner of articulation, and glottal setting, are all important for driving sound changes. So sounds change according to these features. And then this also matters for everyone else because when you know a sound, what you actually know about that sound is what its features are. So this technically matters for everyone, but people need conscious awareness of this if they're going to be linguists, and it's helpful for people that want to learn foreign languages. So I'm going to show you a bit of what effect these features have in a second, right? So these again come into play for sound changes, and the most common example of, or the clearest example of features being important is in assimilation processes where one phone becomes similar to another phone because they're nearby. And basically the reason you do that is to make speech production more efficient. So if you have a feature in one phone that a nearby sound wants, it will basically change one of its features to match a different feature. So this can happen with any of the three features, right? Place, manner, or glottal setting. So first example is very common in English and lots of other languages. For nasal consonants, right, M, N, and to change their place of articulation to match a following consonant. So in this case, right, we have infertile, where this is supposed to be an N, but when we actually go to pronounce it, it comes out as something like infertile. And the reason that happens is that at the beginning, there's right, an N, which is alveolar, next to an F, which is labiodental. And because it's kind of a lot of work to go N and then go F, we just change the nasal consonant so that they have the same place feature. So you don't need to move any part of your mouth, and you can go between the two sounds without having to make any articulatory movements. The same thing happens with inconsiderate, where we have an N at the beginning, but that's alveolar, versus a K, which is velar. So your tongue has to go from the front of your mouth to the back of your mouth pretty quickly. And that's a lot of work that people just don't want to do. So it's more efficient to make the nasal consonant velar so that your tongue doesn't have to move when you go to produce the velar consonant. These cases here are a little bit more complicated. So if you've ever wondered why pumpkin, right, spelled this way, sounds kind of like pumpkin with some of the sounds missing, and same for handbag, why that doesn't sound exactly the way it's spelled, it's because of assimilation. So initially, the nasal is happy because it's bilabial, and the sound after it is also bilabial. M and P both have the same place of articulation, which is bilabial. But we get rid of one of the consonants because going mpk is kind of hard. So instead of going mpk, we go mk, right? We drop out the P because that's a lot of consonants in a row and we just don't really want to do it. So now we have pumpkin. Now the nasal is unhappy because it's bilabial and it's next to a velar consonant. So this also undergoes assimilation so that it is also a velar nasal followed by a velar stop. And the same thing happens here with handbag, where ndb is a lot of consonants in a row, and we don't like that. So we get rid of one of them. We get rid of the D. And now the N isn't happy anymore because it's alveolar and it's next to a bilabial consonant. So the nasal becomes an M instead, so that ham bag is all the same place of articulation. And so this is an example that's very common across the languages of the world, where you have place assimilation. You also have voicing assimilation, where the glottis wants to basically get to act the same throughout all of the sounds that it's next to. So one example of this in English that we have is the S that we put at the end of words to make them plural, right? So the problem is that it doesn't always sound like an S. So for example, in the word dogs, if you listen closely, dogs, that's not really an S sound, it's a Z sound. But in the word ducks, we have actually an S sound here, ducks versus dogs. And the reason that this change happens is because the sound before the plural S is voiced. And so instead of changing the glottal feature to be go from voiced to voiceless, we just make it voiced the whole way through. So dogs, because G is voiced, buds, buds, because D is voiced, and tubs, because the B is voiced. But in contrast to that, we have ducks, right? And the S is voiceless because K is voiceless, butts, because T is voiceless, we have the S voiceless, and tops, S is voiceless because P is voiceless. We also have this happen with the letter X, right, where we get the sound combination KS. So if the sound after it is voiceless, then we pronounce X like X. So external and expert are voiceless combinations because the sound after it is voiceless. But when we say exact or examine, we make the G and the Z voiced. because the sound after it, the vowel, is also voiced. So we have this difference in the pronunciation of the letter X as either x or gz, depending on the voicing of the sound after it. So if it's voiceless, then we get ks, and if it's voiced, we get gz. So that's an example of voicing assimilation. And I have all that highlighted now. That would have been helpful to do earlier, but oh well. Okay, next example, which we can't really find in English, is manner assimilation. So this is when we change something from, for example, from a stop to a nasal. This was actually really cool. I got to see this in one of the splash classes I moderated yesterday in Introduction of Korean. I got to see this actually happen. So it was really fun to see overlap between classes I was involved in. So here we notice a change, right, where we start out with a P, but because the sound before it is nasal, the P wants to be nasal too. But you might notice it also keeps its place feature. So it stays bilabial, but it changes to nasal. So because it's next to a nasal, it becomes an M, but it's still bilabial. And same thing happens here, where this P changes to an M, right? It keeps its place feature, but changes its manner feature to be nasal like the sound after it. Same thing with this T. T keeps its alveolar feature, but changes its place feature to be nasal, not its place feature, sorry. The stop becomes a nasal because it's next to another nasal sound. Same thing with the K. It stays alveolar, but becomes nasal because there's a nasal next to it. And this also happens with L's, where the L stays alveolar, but it becomes nasal. So you get N instead of ul because of the nasal consonants next to it. So those are examples of manner assimilation that we can find in the languages of the world. So that's a kind of example of what happens with consonant features in the languages of the world. But vowels have features too, just like consonants do. The difference is that when we make vowels, our mouths are relatively open, and so there's not as much constriction in the production of a vowel as there is in the production of a consonant. So they have slightly different features. And the features that determine what vowels sound like are height, backness, and rounding, where these two features, height and backness, refer to the position of the tongue, right? Is your tongue up or down, and is your tongue forward or backward, right? And so the different features you can have for vowel height are high, mid, and low, and the different features for backness are front, central, and back. And that tells you where your tongue should be positioned in your mouth when you make a vowel. The rounding is kind of more like an on-off switch, and it says, should your lips be rounded, yes or no? So if your lips are rounded during a sound, then you have the feature round, and if they're not, then you have unrounded vowels. So these are the vowel features we have. And we get to see how these work in the actual real-time production as well. So again, we're going to watch where the position of the tongue is. Because this is a high and front vowel, the tongue should be high and forward. And it's also going to be unrounded, so the lips are going to be kind of flat and just open. So we get to see that. See the body of the tongue presses up against the top and the front of the mouth. And if we compare that to a low front vowel, we'll see that the tongue is still forward, but it's going to be much farther from the roof of the mouth. Okay. All right, and we're going to do one more for each again, because that's just kind of how the slides go when I click through them. Guess not, just the last one. All right, so hopefully you were able to see that the tongue was in different positions during producing the different vowels. You can also have a sound be high, but the tongue is going to be back. And so when we say ooh, the tongue is high up and further back, but the difference is you can see the lips, even in the still, are sort of pursed out, and so that's an example of rounding. Play that again. So you can see still the tongue is high up, but it's pressed more against the velum, whereas during E, which was also high, the tongue was forward at the front of the mouth. And if we compare that to a low back vowel, you can see that the tongue is back and low. Right? So those are the way that the different features behave in identifying what a vowel is. Get my mouse. Again, oo, high and back with lip rounding. Low and back without lip rounding. And so we have a bunch of different vowels in English. You may have learned that there are 5, A, E, I, O, U. That's not true. We actually have a lot more of them, which is part of what makes English spelling so confusing. So we have E and I, which are both high front vowels. Right, E like in beat and I like in bit. Then these vowels, A and E, are still front, but they're produced with the tongue lower. So these are front mid vowels. A like in bait, and E like in bet. And then we have a front low vowel as well, A, like in bat. Then we have back vowels, boot, book, boat, bought, and caught. So all of those are back, and then these, oo, o, and aw, are rounded. Ah is not. So these are the vowels that are either all the way at the front or all the way at the back, and then we have some central vowels where the tongue is just kind of hanging out in the middle. So these two vowels are kind of similar. They're about the same. They both sound like in about, or like in but. And then we have one more vowel that's also mid and central, which is like in Bert. And so these are all of the different vowels in English and the features that sort of make them up. I want to leave time for questions. So I'm going to go through Turkish really quickly. But you can have assimilation of vowel features just like you can consonant features. And when you do, that process is called vowel harmony. So there's this suffix in Turkish, which basically corresponds to the apostrophe S. So it always has a vowel followed by an N. But you can see it changes what this vowel is. So here it's in, here it's un, here it's un, and here it's un. And again, in, un, un. And what determines whether you get in, un, or un is the identity of the vowel before the suffix. So you might notice that all of these vowels and these suffixes are always high. E, u, and u. E, u, u. These are all high vowels. But they vary between front and back and round and not. So if you have a high front vowel that's unrounded before the suffix, then you get E. And if you have a back vowel, right, this also works with ah. If you have a back vowel before the suffix, then you get a high back vowel. So what happens in Turkish is that you copy the backness and rounding properties from adjacent vowels into the suffix. Again, we're running a little on time, so you can double check this later, but you can take my word for it. That does actually happen in vowel harmony. Right, so to briefly summarize what we've learned, basically features make the world go round, and features are important because features are what we know about sounds, and they provide instructions to our anatomy to tell us how to make the sounds that we know. So if you decide I'm going to say T, your brain sends instructions to your anatomy that you need to make a voiceless alveolar stop and then a high front unrounded vowel. And that sort of informs your body how to behave to make the sounds that you want to produce. And so features are how you send those instructions to your body to produce a sound. Features also change depending on their environment, as we've seen with place, manner, and voicing assimilation, and vowel harmony as well. So those are all integral aspects of producing speech, and sounds changing depending on their environment, where features are basically the most important thing, and they are what define the identity of consonants and vowels. So hopefully that is enough time for people to ask questions if they want. Does anybody have questions? You can either unmute or put them in the chat. Either is fine with me. And to give a reminder that Naomi just put in the chat, there is a survey for the class. So it would be much appreciated if you could provide feedback on the class if you have time. Of course, you don't have to, but it does help out the students, not the students, the teachers and the program generally a lot. So that's all from me. Now, does anyone have questions? Okay, well, if nobody wants to ask anything, then I will drop the slides in the chat one more time. And if you don't have questions, or you don't want the slides, or you already have them, then you are free to go on to your next Rainstorm thing. Or I don't know, you can just hang out. I'm done with whatever I had, so if you don't have questions, then you are free to go.